in class either. Can't yawn, can't sneeze, can't cough. All you can do is breathe. That's a joke, people. That's a joke. Don't go home and tell your mom I told you you couldn't do anything when you're. I don't have somebody do that. Statistics. Make sure you understand what the word statistics means. It has a double meaning. Statistics has a double meaning. One is it is a parameter in statistics with the sample. That's one. You don't see that right here. And the other is the grandfather definition, which is basically the collection, the calculation, and the interpretation of data. It's as simple as that. Now you can put all kind of pinky words on it if you want to, but that's what it is. The collection, the calculation, and the interpretation of data. So right now, if you have a book or you printed out your book, you need to highlight that definition. Or you need to take your handy dandy pencil and notebook and write it and put a star beside it, because that is a test question. And that's what I do for chapters 1 and 2. I go through chapters 1 and 2 and I pick out the stuff that's important, and then when we get to chapter 3, we get on the board and we do math. So far I'm on page 5. Those of you that have a book, and page 5 is not, there we go. There we go, population and sample. Make sure you know what a population and sample is. Population would be Anderson County. That would be a population. A sample would be here at the Anderson campus, taking a survey of every student here at the Anderson campus. The sample would be Anderson campus. The sample is usually what than the population? Smaller. Why? Well, that's why it's called a sample. Why would you use a sample? Why don't you just take a survey of everybody in Anderson County? Time and money. So, the whole purpose of statistics and probability, this is the whole purpose, is to take a sample and predict the what? Population. That's what it's all about. Layman's terms, you want to take a sample and predict what the population is going to do with that sample. Is it feasible? Yes, it is. Because we're all creatures of what? Habit. And most of all, if this room was surveyed, it's pretty much going to predict what the campus. So population there would be Anderson campus. The sample would be Math 120 at 8 o'clock on Monday and Wednesday. Okay? Or I could make a group sample, which would be all of my classes. So I could say that the population is the Anderson campus, but the group sample is all of my classes, and that's 6 classes times 30, 150 to 180 students. Okay? That would be a sample. Sample statistics. The things that we use in a sample calculation is called statistics, usually with a little s. So that's the difference, and they're going to talk about that here in a minute. Population, formulas, calculations, interpretation is called parameter. All right? So population equals parameter, sample equals statistics with a little s. Statistic with a big S is the first definition. And they're probably going to talk about that next. There it is right there. Now, one thing that I do usually, it says a statistic is a numerical summary of a sample. Numerical summary can be a collection of data. It can be a calculation of data. 5 people have white cars. Okay, 5 people, that's a statistic with a little s. It means that's the sample at Anderson campus. Where 2,500 people at Tri-County Tech have white cars, that would be a parameter with a little p, meaning the population. It could also mean a formula. One of the things that you're going to find out, and handy dandy transparency, there we go. And this thing gets weird. I was teaching yesterday in calculus and my trig class, and I found out that this thing has when I'm recording, it has a delay. So I'll write an equation on the board, and about 3 seconds later it'll show up. Very annoying. I'm trying to get the help desk to fix that, but very annoying. Statistics are usually in regular alphabet. X bar, S, standard deviation, and so on. But your parameters are going to be Greek letters. Mu, and write that down under, well, where's parameters? Let me, it's down at the bottom, okay. Your mu and sigma are what you're going to see a lot of. There's also summation, but we don't do that. So these are your parameters, meaning population, and these are your statistics, meaning sample. Now, why do you have to learn this? It's not a big deal because the formulas are the same. Why do you need to know? Well, so you don't show your ignorance. And I hate to say it like that, but let's say that you graduated college, you're in your career, whatever it is, let's say you're a nurse, or you're a nurse practitioner, or whatever, and you're a department head, okay? And you go to a meeting for all department heads at AMED. And it's held at this place at AMED, and there's 100 people there because there's 100 department heads. And the people above the department heads are given a big presentation about AMED. And they're using names like sigma and mu, and they're doing statistics. Then you know if they give you mu and sigma, you're talking about the what? The population. The big picture. If you're talking about X and X bar and S, you're talking about what? The sample. So if they're giving you a presentation on the board and you see X bar, then you know, okay, that's the sample. So when you go up and ask questions, you don't go up there and say, I don't know what this X bar means. Then you'll sound like an idiot as a department head. Versus if you go up there and say, I see that the sample is a little bit off of the population mean. Why is that? You don't sound what? Stupid. Okay? That's why you need to know these things. Is anybody going to walk up to you and ask you to find the mean of the blah, blah, blah? They may not. But when you're in a department meeting or a division meeting or a bigger than division meeting, bigger than that, a president's meeting or a president's report, you need to know your stuff before you open your what? Mouth. And that would be a good example of knowing the difference between a population calculation and a sample calculation. So the reason for this is so you don't look stupid in a department meeting. That's the reason for it. And so you know in your calculations which one's which. The formulas are going to be the same. Okay? So hopefully that'll help you out there. And that is a test question because I do want you to know the difference between the two. So anyway, and I'm going to pull this down. And there is parameter, and it's already said that. So you need to highlight parameter and statistic with a little s. Qualitative and quantitative, that's self-explanatory. That's a test question. On any standardized test, anything having to do with statistics, that is a question. Qualitative means quality. Quantity means what? Quantitative means quantity. You've all heard the expression, quality not what? Quantity. Well, that's basically what it is. The quality of a product, the quality or the characteristics of a person, blondes versus brunettes, blue eyes versus brown eyes, white skin versus tan skin, flip-flops versus tennis shoes. All that's qualitative data. because you're measuring the characteristics of a group of people versus their height, their weight, their age. Then you moved into what? Quantitative, qualitative data. How many people in here are male versus female? What is that? Qualitative. How many people in here are 21 years age of older? That's quantitative. Okay? So make sure you know that. Just remember, your qualitative data is your colors. Just think of colors. If you think of colors, then you'll think of colors, flip-flops, shoes, hair, eyes. You see what I'm saying? Qualitative data. Quantitative data has anything to do with what? Numbers. Okay? That's a test question. And I know some of y'all have been through this in high school with your probability and statistics. I'm sorry. Okay, now I get into this a little bit because a lot of people don't understand the difference here. So I want you to write those two definitions down, and then I'm going to explain what these two definitions mean. Because if I was to give you a piece of paper and say this is a test on chapter 1.1 and tell you to write the definition or explain to me the difference between continuous and whatever the other one is, discrete data, 90% of you wouldn't have a clue. Okay? Unless you've had it before. And you probably still don't understand it. So I go through a little, I take off and go to the whiteboard here and show you what the difference is. It might be better if I type it until they figure out what's wrong with my system. I think it's a configuration problem between the software that runs this thing and the software that runs the whiteboard. I think it's some kind of configuration problem. Sorry, somebody turned the volume up on this thing. Yep, I think they turned it up. Yeah. Usually I put it up here because I found that the microphone helps with the background noise. So if I use the microphone, the background noise is decreased a little bit, so that's why I'm using it. Okay, not that you can't hear me. I know everybody can hear me. Now, let's take our handy dandy whiteboard and let's move it over here. And I'm going to write some things up here. Discrete. Discrete has a lot to do with rational numbers. Okay? Rational numbers are those numbers that can be located, that can be predicted. All right? What the heck does that mean? Well, in our number system, there are numbers that you can predict or locate on a number line, such as, and I'll put little brackets here so y'all can see that, 2, 1/4, 3/2, -6, 0.3333, and there's supposed to be a line over that, but I'll have to draw it in a minute. And 0.123, I'm trying to put every kind of number there are, negatives, positives, fractions, trying to show you what I'm trying to talk about. The square root of 25. And I can't put that on there, so I'll put 25 to the 0.5 power. That's the same as square root of 25. And put my little bracket. Okay? Now the discrete numbers go with the rational numbers. In other words, numbers that can be predicted. Can you tell me what the next number is with 2? Yeah, 0.0. Can you tell me what the next, what 1/4 is? Yes, it's 0.25. What's the next digit beside the 0.25? 0. See what I'm getting at? All right. What about the next digit in 0.333333? What's the next digit? 3. It's predictable. You can tell me what's going to come next. Okay? What about 0.123, 123, 123? You know the next digits are 1, 2, 3 because they're repeating. Versus your continuous data. Continuous, if I spelled it right, is irrational numbers. And the irrational numbers are the opposite of rational. They cannot be predicted. I need y'all to get your calculators out, or your phone calculators. It doesn't matter. I mean, you don't have to do anything special. I just need you to type in some numbers, okay? They cannot be predicted or located. Now, what do you mean located? Well, you're going to see it has a lot to do with the prediction. So I'm going to go down here and I'm going to put parentheses, and I'm going to put pi equals, and I'm going to put 2 to the 0.5 power equals, and I'm going to put 7 to the 0.5 power equals. Now I want somebody to give me pi, give me 10 digits, go slow, is 3.141593. 15932 or 15? Okay, I'm sorry. 1592. Keep going. 654. That's all you got? All right, give you $100. Tell me what that next number is. Unless your calculator can tell you, you can't tell me. Why? Because there's no what? There's no pattern. See? How about 2 to the 0.5 power? Somebody give me that. 1.4, oops, sorry. 1.41. Is that it? Okay. Unless your calculator goes further, you can't tell me the next digit because there's no what? If there's no pattern, you can't predict it. If you can't predict it, you can't what? Locate it on a number line. Why can't you locate it on a number line? Because there's no end to it. It keeps what? It keeps going. So you can go 3.14, 3.141, 3.142. In other words, it keeps moving. It doesn't stop. That's why these numbers that I'm putting up are always those numbers that is kind of like to a computer, try to win tic-tac-toe. Why can't you win at tic-tac-toe? Because that's one of those games that you just play because you're bored and there's no skill to it. You see what I'm saying? Some of y'all see it, some of y'all don't, some of y'all just sitting there. Okay, yeah, board games. Some of them, huh? Yeah, they tried to play tic-tac-toe. They got that from Star Trek. Star Trek, in one of the original series of Star Trek, the computer took over the Enterprise, and they tried to get it to figure the last digit of pi or play tic-tac-toe. I can't figure out which one it was. But it's the same thing. If I ask you to find the last digit of pi, after about 10 pages, you'd quit. Because it takes you about 10 pages to get about 7 digits. All right? Past the decimal. So after about 10 pages, I know some of y'all would quit. And then there'd be one person who'd take it 15 pages, and then they'd quit. Because 15 pages would give you about 12 digits, and then you'd say, bump it. All right? So what about 7 to the 0.5 power? Somebody give me that one, because I don't, 2.57, or what is it? 645, 9, 751, 3111. Now, somebody could go out on a limb and say the next digit is 1, but I wouldn't put money on it because there's no pattern. So that's the difference between discrete and continuous, and it's the difference between rational and irrational. And I guarantee you somebody in here has gone through 3 years of high school math and didn't know the difference between rational and irrational. Now you do. It's the same as discrete. And so discrete would be anything in science or statistics having to do with what? Counting. I told y'all about sneezing, didn't I? Okay, don't do it anymore. All right. Then what's the opposite of counting? No, close. Measuring. Let me give you an example. Let's say that there's I don't know where a fire hydrant is, but so let's say there's a fire hydrant down there at the bottom of that hole down there. And I brought in a box of measuring devices. What do you mean measuring devices? Well, some of them are yardsticks, some of them are rulers, some of them are measuring tapes, some of them are measuring tapes with a digital readout window right above it. Y'all seen those? You pull the measuring tape out and it reads the distance for stupid people. I'm sorry, for people that can't read the, okay? And some of them have little marks that have each little increment because you can't read the measurement. So they put all these little numbers. And then you got the carpenter's folding type ruler. Y'all seen those? They're old, but carpenters, all kinds of different. So I bring in a box of those, and I tell everybody in the class to go down there and measure the height of that fire hydrant. And come up here and write the answer on the whiteboard. Write the height on that board there. How many different answers would I get? Oh my gosh, I would get 30 different answers. Why? Because 10 of y'all would just say 3 foot because you don't know how to read the measuring tape. Okay? And you would say 3 foot. 2 or 3 of y'all would go out there and kick around the bottom of the fire hydrant and find out where it meets the water pipe, and then you would measure from there. 3 or 4 of you too lazy, you wouldn't even kick around it. You just measure from the top of the what do you call that stuff out there? Mulch. And you just 2.5 feet when it's really like 3 feet because you have to kick down and find it. All right? You see where I'm going with this? And 5 or 6 of y'all that actually took it seriously would read the tape and you get, okay, that's 3 3/8, and then the person right next to you would say 3.5, or 3 feet 5 inches, or 3 feet and a half inch. In other words, you would get totally different. Why? Because you're measuring. Versus, what if I told you to go out to the parking lot and the gate's shut? We shut the gate. Let's say we shut the gate. Nobody comes in, nobody goes out. And I tell you to count the number of cars. That means non-SUVs. That means non-motorcycles. That means non-trucks. Cars. And I told you to count the number of cars that's in the parking lot, excluding SUVs, excluding motorcycles, and excluding trucks. How many different answers would I get? I wouldn't get different answers. I would get the same answers. Why? You're counting versus what? Measuring. So when you get asked this, and you're going to be asked this 2 or 3 times on the test, because this is a very important question. When you get asked this, if I tell you to measure the height of a tree, you'll tell me it's what? I saw that. That was a yawn. That was a yawn. I saw it. You yawn 2 more times, I'm going to throw you out of here. All right? What is measuring a tree? I just told you. Measuring. What is it? It's continuous. Counting eggs in a basket. Discrete. Now, everybody says, oh, that's easy. But when I put it on the test, y'all get it wrong. So, y'all figure that out. But that's the difference between discrete and continuous. And you would be surprised on how many people don't know the difference between the two. Okay? So that's that. So make sure you make a note of it, put stars beside it, because I know at least 2 or 3 questions. I give you 2 or 3 questions, and it's simple, multiple choice. Is it continuous or is it discrete? And for some reason, y'all don't get it right. I don't know why. I try to make it simple and y'all screw it up. But anyway, hopefully this class is special because y'all did what y'all were supposed to. So hopefully y'all will get them all right and prove me wrong. Okay? All right, next thing. And that's where they're telling you here. Now, let's read the definition they give you. Is a quantitative variable that has either a finite number or possible values of a countable number or possible values. The terms countable means that values result from counting, such as 0, 1, 2, 3, and so on. A discrete variable cannot take on every possible value between any 2 possible values. I think I go with mine. A continuous variable, this ought to be good, is a quantitative variable that has an infinite number of possible values that are not countable. A continuous variable may take on every possible value between any 2 values. Tell me how many numbers are between 0 and 1. Infinite. That's continuous. What do you mean? I only know of 1 half. Yeah, what's between, think of wrenches. Okay, I didn't say wretches, I said wrenches. Okay, wrenches. Some of you guys that have tools, some of you women that may have tools. How many wrenches you have between 0 and 1 inch? There's a lot of them. There's a quarter, there's 3/8, there's 7/16, there's 1/2, there's 9/16, there's 5/8, there's 3/4, 11/16, 3/4, 13/16, 7/8, 15/16, and 1 inch. Okay, all of those wrenches are between 0 and 1. Now, you can actually get other wrenches that are between those. Nobody ever uses them, but you can actually do that. And how do you get them? You take the 3/8 and you divide by 2. You take the 7/16 and you divide by 2. You take the 1/4 and divide by 2. You take the 3/4 and divide by 2. You divide by 2 and divide by 2, and you keep, it's called interpolation, you keep getting different numbers. And the numbers between 0 and 1 are 2 and 3, or 4 and 5, are infinite. There's infinite amount of numbers between those 2 numbers. And that's the difference between discrete and continuous. And everybody feels good about themselves, right? So you don't have to put smokestacks on your 4-cylinder truck. All right. You ever seen that before? It doesn't look good. It doesn't sound good either. But people that put smokestacks on their truck are weird anyway. Sorry. It's a fact. I can't get the next page to come up. That's great. What's the purpose for smokestacks while we're talking about it? While the computer's on? Somebody tell me what the purpose for smokestacks are. Huh? No, I'm talking about the original purpose. Smoke. Well, think about it. In the 1950s and the 1940s and 50s, when they started making these BA trucks, all right, to transport things, where was the exhaust? Under. And what did we not have in the 50s and 60s very much in cars? Air conditioning. So how did you have air conditioning in the 50s and 60s? You what? You rolled down the window. So everybody had their windows rolled down. You pull up to a red light beside one of these BA trucks, and what happens? You die of, what do you call it, carbon monoxide poisoning. So what did they do to divert the fumes from these BA trucks? What did they do? They put them on smokestacks. That's the original reason for smokestacks. Don't believe any of this horse crap about horsepower. It makes it better, it makes it faster. You're an idiot. The original reason for smokestack was to take the smoke out of the cars at a red light. That was the original reason. So, if you know any of these people that have smokestacks, it doesn't add up. Okay? And we still don't have anything. So this is great. Let's see if I can hit the refresh button. I hit the refresh button. You got anything on yours?
I had to shut my home computer.
It went crazy. Well, believe it or not, I've never had this happen before. It's Bush's fault. It's all Bush's fault. Okay. Well, we'll just sit here and talk about current events. I'm kidding. Somebody would get offended. All right, well, we'll have to continue. Let me borrow your book for a second. I know. It's called innovation. I'll just go by and we'll write stuff down. I can still use the computer. I need to start thinking, I need to bring a book to class every once in a while. Thank you. Okay, make sure you read page 10. That's that's not a test question, but I want you to read it. It's the brown box right there. The different levels of measurement. There's the nominal level, the ordinal level, the interval level, and the ratio level. All I want you to do is read over those and maybe write them down in your notes. Be aware of them. I usually don't give you a test question on those, but I want you to know them. No, I've already said them one time. I don't repeat myself. Nominal, ordinal, interval, and ratio. It's on page 10. Somebody tell me when the internet comes back up, please, because I don't like doing this. See, the phones and brain tumors. It's not a tumor. That comes from Arnold Schwarzenegger and what's that? Kindergarten Cop. It's not a tumor. On page 16, I told you I was a movie nut. I'm sorry. I can tell you a lot of quotes out of movies. I love movies. On page 16, observational. Observational study versus a designed experiment. You ever seen these videos of people, whether it's on a commercial or whether it's on TV, of people being recorded while they're sleeping? Sleep apnea. You ever seen those? It's night vision, and you watch the person turn over and turn flips and do all that, and wake up and lay back down, and you ever seen? Y'all ever do anything? Okay, you seen? Okay, 1 person out of 30. Good. All right. Well, anyway, what is that? Is that an observation or an experiment? It's an observation because you're not doing anything. It's an observation. You're not doing anything. You're not controlling anything. Now, some people say you're controlling it because you're watching it. No, you're not. You're not controlling it. What's so funny? Come on, share. Oh, I'm sorry. Okay, y'all leave, okay? You don't make fun of people in this classroom. All right. What is an experiment? An experiment is putting a rat in a maze and putting cheese in different parts of the maze. That's an experiment. Why? Because you're controlling the experiment. Now, okay. Sneeze again, you have to go. If you put a rat in a maze and you don't do anything, what is that? Observation. What if I split the class into 2 groups, and I give y'all a red pill, and I give you a blue pill. The red pill, you get out of the matrix. No, I'm sorry. The red pill, I tell you, is this super duper drug that makes you lose 10 pounds a week. And then I don't tell the blue people, I tell them the same thing, and send y'all off to your homes. You're supposed to take the pill once a day and do whatever you want to do. And I come back, and the people in Group A lost an average of 10 pounds apiece, and the people in Group B lost an average of 8 pounds apiece in the sugar pills. Okay? Is that an experiment or an observation? It's an experiment because I'm controlling it. All right? If you control it, if you have any input into the observation, it becomes an experiment. That's the difference between the two. That's on page 16. No, I'm not going to do 17. I don't feel about that. Census. Everybody knows what a census is. If you don't tell anybody. All right, page 22 and 23. What is a random sample? A random sample is me putting everybody's name on a piece of paper that's the same size piece of paper, folding it the same way, putting it in a fishbowl, mixing them up, and then picking one number out, or picking one name out. Why is that a random sample? Because everybody has the same what? Chance of being picked. And that's what you need to remember about a random sample, those words. Everybody has the same chance. So what about well, you couldn't say throwing a dart at a wall with balloons is a random sample, because you're not going to throw up in the top right hand corner. You're going to throw what? Straight ahead. So that's not a random sample. But another random sample, basically anytime you put everybody's name in a fishbowl, a hat, or whatever, that's kind of a random sample. What about me putting seat numbers, or like row 1, seat 1, whatever. Assigning a seat number to each seat and putting those seat numbers in a hat. Is that a random sample? Yes, because everybody's got the same chance. Okay? So random sample, make sure. The only difference between a random sample and a simple random sample is a simple random sample has to do with a group. So instead of putting your names in a hat, I would put row 1 in a hat, row 2 in a hat, row 3 in a hat, row 4 in a hat, row 5 in a hat, row 6 in a hat, row 7 in a hat, row 8 in a hat, row 9 in a hat, row 10 and row 11. And instead of picking one person, I'm picking what? A group. That's the difference. I'm not gonna test you on simple random sample. The random sample is a test question. Okay? You may see that. No yawning. Anybody will yawn twice, you get close. Did you ask your dad about going to Six Flags? What did he say? He didn't say
We
anything.
talked about some girl,
I think I know who that was. I'm gonna stay quiet. Tell him that the one that I went with was my ex. I don't know if he knows that or not. I don't know if he knows I'm divorced now.
Yeah, he does.
How did you find that out?
We stopped talking.
He stalked me on Facebook. He's a pervert. All right. Stratified sample. Did he tell you about the raccoons? He didn't tell you about the raccoons? Okay. Stratified sample is another sample that has to deal with, I can't believe he stalked my Facebook page. Stratified sample, that's group. A stratified sample would be like if you go to a voting precinct What kind of people are gonna be at a voting precinct? There's two kinds of people.
Over 18.
No, that's a good answer. Republican and, well, what about independent? Yeah, there'll be one person there that's independent, all right? But the rest of them, 90% is gonna be Republican and Democrat, all right? Do I agree with that? No. If you want to know the truth about it, I wish there was 5 parties. I wish there was 6 parties. Yeah. Yeah, they are, and they're on their way to doing it. But I'm not going to go there. In my opinion, one party is ruining the country more than the other. That's just my opinion. All right. Stratified, I told you that was like grouping. Yeah. A cluster sample would be like a state, like where a voting precinct would be like stratified, a cluster would be like a county precinct. In other words, a county voting, the way the county votes versus the way that a precinct is voted. Stratified versus cluster. Cluster is a little bit bigger. Okay? Oh yeah, systematic. Systematic would be like picking the 7th person, every 7th person in the class I pick to make an A in the class. All right? I'm just going to give them an A. All right? That would be systematic. Every 7th person I pick out of the phone book would be systematic. Anything showing a what? A pattern is systematic. That's a test question. Systematic is a test question. Convenient sample is the least accurate. Convenient sample would be like, I'm working at a radio station that plays predominantly classic rock music and asking people on the air, how many of you out there like rock music? Why is that a convenient sample? Because most people that are listening to my station like what? Rock music. That would be a convenient sample. Usually convenient samples are usually not the best way to go. What's the best way to go? Random sample. Random sample is the best way to go. That's why if I gave you a project to do, which I really don't want to, but you're going to have to one of these days, because this is people above me that don't remember about teaching than I do. Go out and find, that would be a good thing. It is election year. I could give y'all a project about the election. That would be a good thing. It might count for a test book. I'm thinking about doing that. That'd be good. And that way people would learn more about the election. Think about doing that. But a random sample would be best. Let me give you an example. What if I gave you a project to go out and do, is the internet back up yet? Okay. Well, it says this page can't be displayed. What? Okay. If I decided to go out and ask questions about the election and I wanted to go out in the parking lot, would that be a random sample? Kind of. Yes, it would be, because unless I picked all females or I picked all males, then it wouldn't be a random sample. But if I pick, I'm not going to pick every 4th person. A systematic random sample is not bad. It's not bad at all. In fact, in a case like that, a systematic random sample would be better than a random sample. Because a random sample, it'd be hard to do, coming out of the door. But a 7th person or a 10th person out of the door would be better because they're coming out of the door. You see what I'm saying? A random sample would be least perfect there, or less usable there, because you might be tended, or you might be led to pick a certain person versus a systematic random sample. So a case like that, a systematic random sample would be better than a random sample. Okay? Does it matter? Yes, it matters, but between the systematic and random, it really doesn't matter. The reason you would do a systematic is mainly for convenience, to keep it level. In other words, not be biased. We all have a natural tendency of bias. Okay, we all do. A lot of the pollsters. What is very common right now on the news? The election. And what goes with the election? No. Polls. Let me ask you a question. Do you notice anything interesting about the polls? This is statistical. But do you notice anything interesting about the polls versus the rallies for Clinton and Trump? I'm sorry, what? Exactly. The media polls are showing that Hillary's winning the election. But the rallies are showing what? That Trump is bringing in more people. Now, people are having a problem with that. Because if Hillary was winning the polls, then why isn't Hillary bringing in the people? Make you think. Maybe we ought to do a project on that. No, I'm just kidding. But that's a statistical question. People are questioning what? The polls. People are questioning the polls because the polls are not showing what's happening in the real world. And they're having a problem with that. A lot of people are having a problem with that. Can statistics lie? It depends on who's collecting the data. If I want to go out here and show that people at Anderson campus are drunkards, I could do that. I could do it in a heartbeat. All I would have to do is question most of the guys that come out of the door. Okay? Because the ones that are most likely to drink are the guys versus the women. And I know that because I'm a math teacher, okay? That's the ones that, so I go and I do nothing but guys that come out of the front door at Tri-County Tech, I could prove that Tri-County Anderson campus is full of drunks. All right? So what does that mean about the polls? If I want to prove that Hillary Clinton's going to win or Trump's going to win, all I have to do is poll what? Poll the people that I think are going to vote for Clinton or Trump. Now, I would really suggest, if you want to learn anything about statistics right now, now is the time to do it because it's right in front of you. One of the biggest things of the year is the election. And a lot of statistics. What time is it? Because y'all are getting fidgety, okay? I still got 6 minutes, okay? So chill out. Really a good time to focus in on the election because that's your statistics at work. You see your bias, you see your collecting of data, you see your margin of error, and then you see what's happening in the real world and you compare it to what's going on with the polls. If the polls don't line up, then somebody's what? Somebody's lying. All right, everybody make a note. Page 34 is where we're stopping. And somebody tell me what section that is, because I just closed your notebook. What section is that? Okay, so we're in 1.4. So we covered pretty much chapter 1 today. I've got a couple of sections. So what does that mean we're going to do Monday? Probably finish chapter 1 and finish chapter 2. Okay? Does anybody see anything with the internet right now? The intranet is probably working. Hold on. What are y'all doing? Y'all like to sit down, please? That's rude. Yeah, I've tried to say it like Bon Qui Qui, and I just can't do it. I will cut you. Okay, I guess it's not working either. All right, I just count everybody here today. Continue to work. Okay, now you should be able to start your homework on chapter 1. We're in 1.4, so if you want to work on 1.4, if you just want to work to 1.3, that's good. That's not a big deal. Just go ahead and start working, and y'all have a good weekend. Now you can stand up and lead. It's called professionalism.
Talk to me about my email.
Oh yeah, let's Let me send some stuff to, well, I can't do anything now.
Do you need to just get in contact with the IT desk?
No, when did you add the course?
Like last minute. I was
Okay, that's fine.
Yeah.
Send me an email this weekend or whenever it gets back up. Send me an email, say, please send me handouts, blah, blah, blah. And I just added at the last minute, so I'll remember.